Now, let's talk about rational exponents and roots. Now let's talk about rational exponents and roots. So when it comes to exponents and roots, that basically is with the graphs. So let me give you an example of what it means. So say we have y equals x and y equals negative x. Well, when we graph both of these, we're going to see that when it's negative x, it's flipped over the y-axis. So that's what it's always going to be. Even if we had a number like y equals 2, 3, well, if we had y equals 2, 3 minus x, then it would have been reflected over the y-axis. So this means that if they have a negative on the x, then it is flipped over the y-axis. That's to kind of get the idea of it. Now, say we had an exponent on there. Let's take, for example, y equals x squared, y equals x fourth, and y equals x to the power of 6. So if we were to graph this, just going to do a little quick sketch, nothing perfect. If we were to graph this, we see that this one's like so. This one's like so. And this one's like so. So we can see that it gets what? It's getting what? Narrower. It's getting more narrower. So when it's an even exponent, the higher the exponent, the more narrower it becomes. So with the rational exponent, when it is even, the higher it goes, the more narrower it becomes. Now, what about the odd exponents? If we had y equals x cubed and y equals x to the power of 5. Let's look at what it's like when it's with odd. This one is like so. And when it's x to the power of 5, it's like so. So what do we notice? That when the rational exponent is odd, then the higher, the wider it gets. The wider it gets. So for the even rational exponent, the higher, the more narrow it becomes. For the odd rational exponent, the higher, the more wider it becomes. And also, if it's an even, it's always going both up or both down. And if it's an odd, it's going one side up or one side down, just as if we were searching for an odd or even function. So this is for rational exponents and roots.